Yesterday we did addition, subtraction. Ooh, excuse me. Today we're going to multiply and divide. So we'll multiply first, multiplying complex numbers. So before we multiply complex numbers, let's talk about what happens with these i's when we start multiplying. If I had 2i times 3i, tell me what you think that would equal. 6i squared, right? Because I'm multiplying. But here's the question. Yesterday I told you I equals what? Square root of -1, right? What do you think then I squared equals?
Negative.
You're right. No. Think about this. We talked about opposite operations when we were solving. And we said if you ever had this and you needed to cancel the squared out, you did what? Square root. So would you agree that those just cancel each other out? So if I square the square root of -1, what do you get? -1. The squared and the square root just cancel out. Okay? So I squared is -1. Does that make sense?
I squared is -1. 1 is the square root of negative.
Correct. Okay. So if I hook I squared to a number, tell me what it does to that number. It multiplies by -1, which switches the sign. So 6i squared becomes -6. And I'm done. Okay. So anytime you see I squared, we do have i's, but when we start multiplying, we'll start getting I squareds. You leave an I, but if you have an I squared, you drop it and change the sign of the number. Because because I squared is -1. So you literally replace I squared with -1, and it becomes 6 times -1, which is -6. Anytime you have I squared, drop it and change the sign of the number. I'll give you a second. Yeah. Go back. What if I had -3i squared? What does that become? It'd be 3. If I had 5i squared, that would become what? -5. Y'all see where I'm going with that? The I squared drops, the sign on the number changes. All right, so let's multiply. Because complex numbers have 2 parts, what are the 2 parts they have? Imaginary and a real part, right? Yeah. So it's going to look something like 2 plus 2i. We'll use it. That's good. What? I was just showing you what happens with an I squared because this needs to come up. This is an example of multiplying. Yeah, I'm sorry. All right, so what we're going to have to do is we're going to have to FOIL this out or distribute it through, okay? So start with the first. It goes to everything in this parenthesis, right? What's 2 times 2? 4. And 2 times 2i is 4i. So I'm done with that first piece. Now take the second one. It's got to go to everything. 3i times 2 is 6i. And then 3i times 2i, 6i squared. Here's where my I squared is going to start popping up. Now, I need to simplify this. These two are easy to simplify, right? Those are like terms. What do they add to? 10i. How about this 6i squared on the end? It changes. It changes from 6i squared to -6. Now it's like terms with which one? The 4. So what's 4 and negative 6? Negative 2 plus 10i. That's your answer.
Wait, what? Hold up.
I just added the 4 and negative 6.
You did it.
Yep.
My equation.
Let's do another one.
That's all I gotta do.
For multiplying, yeah. Dividing's a little bit harder. 9 minus 2i times negative 4 plus 7i. Let's multiply that. What do I do first? Take 9 and distribute. So I'm going to start with the 9. 9 times negative 4 is negative 36. 9 times 7i. What?
I mean, nah.
What's 9 times 7? Y'all don't know the little trick on your hands?
63.
Alright, so hold your hands this way. This is your first finger. Look, I'm going to show you this. This is your first finger. So count over to 7. 6, 7. Hold that finger down. There's 6 fingers on this side, 3 fingers on that side. So it's 63.
I know
People do that cheat.
Okay. I still do it like that. Alright. It works though. It works for every single one of them.
I
Look.
always got in trouble for not knowing my times.
9 times 5, 45.
Yeah. Do not talk about. Oh, you can do that. Do not talk about. Take one of them. There's still 4 fingers.
What?
You said do not talk
It only goes through 10, Brady. It only goes through 10. Alright, let's do the negative 2i.
He's not as serious about it too. Do not talk about it.
Negative 2i times negative 4.
Plus 8.
Plus 8i. Negative 2i times 7i.
Nah, 14i squared. Negative 14i squared. 14i squared. Negative 14i squared.
I would go ahead at this point.
Change that.
Change that. Right now it's negative 14i squared, so it's going to change to what? Positive 14. Now gather your like terms. Negative 36 and positive 14 gives you what?
Negative 36.
What?
You said negative 36.
Yeah, negative 36 and positive 14.
Oh, no.
What does that add to?
-22.
Negative 22.
So it's 2i, negative 27.
Yes.
So this is the extent of multiplication.
Yes.
Alright, we should just
Okay.
jump into it.
Now sometimes they might have an imaginary on the outside instead of 2 complex numbers, so maybe it looks something like this. 3i times 4 minus 7i. In which case you're still just distributing through. 12i minus 21i squared. There's just nothing to combine. Let's see. We'll make sure I cover everything on this book is sad. What happened? It's falling apart. Okay. Let me ask you this. This is actually, write this one down because this is number 24 in your homework. For real, we're gonna work it together. One minus I to the third.
So what number is this on our homework?
24.
So wouldn't it, if you were to do that, wouldn't it just make the number negative?
Well, what happens, this exponent tells me how many times to write it. Okay.
So yeah, if you multiply 2 of them together, it's
Yes.
positive, and the last one turned back.
So I need to multiply 2 at a time. All right. Don't try to multiply Jalen 3 at a time. Do only 2 at a time, right? That's right. So I'm going to go ahead and FOIL out the first two. 1 minus I minus I. What's negative I times negative I? I squared. Positive I squared, right? These small numbers will throw you sometimes. I squared becomes what? Negative 1. Now look what happens. What is 1 plus negative 1?
Positive. Nah.
1 plus negative 1. 0, right? So these cancel. What is negative I and negative I?
Positive 1.
Adding them, not multiplying. Negative I plus negative I.
2.
Negative 2 I. But I'm not done because I only did these two. Now I drop this one down exactly and I do 1 minus I. Now this is just to distribute. I'll let you finish that one on your own since that's a homework problem, but that'll just get you started on it. All right, let's divide.
Hold up.
Okay. I'm going to show you dividing by an imaginary and then dividing by a complex, and I'll be done. What'd you say, Bryce? Thank you. What's the difference in imaginary and a complex?
Imaginary.
No. Come on, y'all. What's the difference in an imaginary number and a complex number?
Complex combination of imaginary.
Yes, they do. Huh?
Complex is imaginary, is the combination of imaginary and real.
That's exactly right. Complex is made up of an imaginary and a real. Imaginary just is a number with the I on it, okay? All right. If we're dividing by an imaginary number, 5 over 2i. Remember how we talked about we couldn't have a radical in the bottom?
Yeah.
Is this a radical in the bottom?
Yeah.
Yeah, why?
I.
What does I equal?
-1 squared.
Square root of
Square root.
-1, right?
Yeah.
All right, so when we rationalize denominators, if we had something like 5 over the square root of 2, how did we get rid of that radical in the bottom? Times it by what?
2.
Square root of 2, right? So what can we times it by here to get rid of the radical?
2i.
Square root of -1, which is I. You don't have to worry about the 2 in front. You're trying to worry about the 2. You don't have to worry about that because that part doesn't have a radical on it. All you have to do is multiply. Yeah, I is a radical. Multiply the top and bottom by I. I put an I here and an I here. And up top, I get 5i. On the bottom, I get 2i squared, which is really what? -2.
2.
Do I still have a radical on the bottom?
Nope.
No.
Now you got one on top.
But that's okay. I can have it on top, just not on the bottom. Remember when we did it? Yes, you did.
Oh, see, that's solved out.
Bryce, you are exhausting.
That's solved out.
Yes, that's simplified. That's simplified.
Oh, yeah.
So it's gonna get harder because he said this is supposed to be harder.
The imaginary is easier. The complex that I'm fixing to show you gets a little bit harder.
Gotcha.
All right. Dividing by a complex. This is the hardest part, I think, of this whole section. So if you get this. So I might have something like 2 plus 3i over 5 minus 2i. I can't have the I in the bottom. But if I just multiply by I this time, it's not going to go away. I have to multiply the top and the bottom. Multiply top and bottom by what we call the conjugate. Now, this is a big fancy word for a really easy concept. Okay? The conjugate of 5 minus 2i is 5 plus 2i. What did I do? I changed the middle sign only. That's what a conjugate does. It changes the middle sign only. 6 minus 4i, what's the conjugate?
6 plus 4i.
2 plus 8i, what's the conjugate? See what we're doing? So the only thing I have to do is find the conjugate, and it's the conjugate of the bottom, because the bottom is where the problem is. So what's the conjugate of 5 minus 2i? 5 plus 2i. And if I do it to the bottom, I also have to do it to the top. So now my division problem becomes a multiplication problem, because I'm going to multiply this times this, and I'm going to multiply this times this.
And then you just gotta foil them across.
So I'm foiling up top, and I'm foiling on the bottom.
It don't seem like it's hard. It would seem like it's a bunch of
Distributing. So let's take it through the top. 2 times 5, 10. Plus 4i.
How do you get 4?
I distributed the 2 through that set of parentheses. All right, now the 3i times 5. Now 3i times 2i. Right. Also, exactly. And we're going to go through and change all that in just a second. I'm going to go ahead and FOIL the top and the bottom first, then I'll go through and simplify. On the bottom, 5 times 5, 25. 5 times 2i. Now move to the next one. Negative 2i times 5. And negative 2i times 2i. Negative 4i squared. All right, let's start adjusting. Our I squared, somebody said earlier, go ahead and change them. This is going to become negative 6. How about on the bottom, what does negative 4i squared become? Positive 4. All right, look up top. Okay. Look up top. Add the numbers without I together, and what do you get? 4. Add the numbers with I together.
19. How you get 4?
10 and negative 6.
Oh. Alright, we'll just hold up.
All right, look at the bottom. Numbers without I. 29. How about numbers with I? 0. That's, remember, that was the goal, is we didn't have any I's in the bottom. That's your answer.
That's my answer.
That's your answer.
Don't you got to solve that? So what would you do at the bottom with squares then? What am I going to do then?
What are you talking about?
What fit with
Don't make this
squares?
thing complicated.
Oh, let me record this so everybody sees Bryce's example. Okay. We got to change it.
Foil.
And it's got to go top and bottom. You don't have to worry about doing anything with the top numbers yet. I told you.
I'm straight.
All right. Normally, if I ask somebody to give me a random number, it's not 80.
We
23.
got a multiply
Okay.
that?
Yep.
All right,
What's
1840.
1840? Brady with the calculator, give us 80 times 17.
1360.
13 what?
60.
You got a lot of work.
Good thing you don't make the test up. 5i times 23.
That should be like 150, I think.
The difference.
And then 5i times 17i.
It's like, I think it's like 85.
You have a calculator. What do
Oh, I
you
really
mean?
did.
What is it? 85?
So,
I squared.
yeah.
Let's move to the bottom.
23 times 23. 529.
It's like 529, yeah.
Okay. 23 times 17i.
391.
Negative 17i times 23.
And 391.
No, negative 391.
It's the same thing.
Negative 17i times 17i.
Times 17 is 289. I squared. Well, now you just gotta say.
Let's change all our I
Yeah,
squareds.
if you fail the test, then you'd be screwed.
Negative 85 and positive 289. How about your numbers without I up top? 1840 and negative 85?
What's this?
I got you.
17.
It's 17 something.
I think it's like 1765.
Is it?
But I'm just going off the top.
Okay.
1755.
55.
You were close.
Wait, what y'all at?
1840 and negative 85.
Alright, and the other one's
1360 plus 115.
1475.
No, that's 1400.
That one's got an I on it.
1475.
How about at the bottom? 529 and 289. And the I's canceled out.
Alright,
Woo! Bryce, we appreciate that, buddy.